Hello everyone. In this video, I'm going to continue to the second part of my video about vector equations of planes. In my first video, I have showed you how to find vector equations of planes when normal vector is given either directly or indirectly in the question. In this video, I'm going to talk about how to find the vector equations of planes if the normal vector is not given. If you haven't watched my first video, I suggest you watch the video first. Besides this, in this video, I'm going to use the intersection line to solve one of the questions. So I also suggest you watch my video about intersection of three-dimensional vectors before you come back to this video, so that you can understand better for the topic that I'm going to discuss in this video. You can find all the links of my videos in the description. If this is your first time here, and make sure you subscribe my channel by hitting the subscribe button below so that you won't miss any videos later. If you find that this video is useful, please share to your friends, to your students, or to anybody who needs this. So, let's start the lesson right now. In the first video about vector equations of planes, we have learned that when finding vector equation of a plane, we need one position vector of a point which is on the plane, and also we need one normal vector which is perpendicular to the plane. The position vector can be taken from the coordinates of a point which is on the plane, or can be taken from the position vector of a line which is on the plane, or can be taken from the intersection point of two lines. For normal vector, the normal vector can be taken from the perpendicular vector it is given in the question, or can be taken from the direction vector of a line which is perpendicular to the plane, or can be taken from the normal vector of another parallel plane. However, if the normal vector is not given, so the normal vector we can calculate it by using u times v, where u and v are two direction vectors that are parallel to the plane, but the direction vector u and direction vector v, they are not parallel to each other. So when direction vector u multiply with direction vector v, then the vector product is a vector which is 90 degrees to the plane. This vector can be taken as the normal vector of the plane. So generally, if we want to find the normal vector, we need two parallel direction vectors. The direction vectors can be taken from any vector that is parallel to the plane that is given, or the direction vector can be taken from the direction vector of a straight line which is parallel to the plane. Or when we are given that two planes are perpendicular to each other, then the normal vector of the first plane actually is parallel to the second plane. So the normal vector of the first plane can be used as the direction vector of the second plane. Or if we are given 2 points, so from these 2 points, we can find one direction vector, that is direction vector AB can be calculated by using the position vector of B minus position vector of A. Or if we are given more than 2 points, then from here we can find more than 2 direction vector. Other than AB, we can find direction vector AC, we can find direction vector BC. Or if we are given 2 planes intersect each other, then the direction of the intersection line is equal to normal of the first plane times normal of second plane. Then the direction of this intersection line can be used as the direction vector of the plane, but we must make sure that the intersection line is on the plane. Now let's try this example. A triangle with vertices PQR. Find the vector equation of the plane PQR. So if we want to find the vector equation of a plane, we need one position vector of a point which is on the plane. Here we have 3 points, so we can use either one point. Then after that we need a normal vector which is perpendicular to the plane. Here we are not given any normal vector, so we need to find any 2 direction vector such that when we multiply the 2 direction vector, we will get one normal vector. In this question, we are given 3 coordinate points as the vertices of the plane. So from this diagram, we find that we are able to find more than 2 direction vector. One is direction vector PR, direction vector PQ, or direction vector QR. We simply choose any 2 direction vector. So let's say I choose direction vector PQ. So direction vector PQ can be found by using the position vector of Q minus the position vector of P. So the position vector of Q, we can get it from the coordinates of point Q, and the position vector of P we can get from the coordinates of point P. So when we minus, we will get the direction vector of PQ. Then another direction vector that I choose is PR. So PR is equal to OR minus OP. So OR is the position vector of point R, and OP is the position vector of point P. When minus, then I'll get the direction vector of PR. Now I have got 2 direction vector. So now I try to multiply these 2 direction vector, and I find the vector product of the 2 direction vector, that is 16, 10, and 18. Then I factorize the 2 out here, so the normal vector becomes 8, 5, and 9. So when I sub the vector into the formula, so this is the normal vector, this is the position vector. So here I choose point P as the position vector of the plane, and this is the normal vector. Then when I find the scalar product of these 2 vectors, it is equal to 11. So this is the vector equation of the plane PQR. Now let's try another example. Find the equation of a plane passes through the 2 points and the plane is perpendicular to another plane. When finding the vector equation of a plane, we need one position vector of a point which is on the plane. In this question, we are given 2 coordinate points, so we can use either one. As for the normal vector is not given, so now we need to find any 2 direction vector such that when we multiply the two direction vector, we will get one normal vector. So in this question, since we are given 2 points, and from these 2 points, we can find one direction vector. So to find the direction vector between these 2 points, I can use the position vector of one of the point minus the position vector of the other point. So here I use the position vector of 0, -2, 5 minus the position vector of -1, 3, 1. Then I'll get the direction vector. So this is the first direction vector. Now I'm going to find the second direction vector. In this question, we are given that we have another plane that is perpendicular to the plane that we are going to find. So from the equation of this plane, we can see the normal vector of this plane, that is 5i plus 4j minus 2k. So the normal vector of this plane, actually it is parallel to this plane too. So means the normal vector of this plane 1 can be used as the direction vector of this plane 2. So now I have the second direction vector, that is 5, 4, -2. So now I can find the normal vector, that is I multiply the two direction vector. And the vector product of these two direction vector is -6, 22, and 29. So this is the normal vector that we are going to use. So now I have the position vector and I have the normal vector. So now I'm going to find the vector equation of the plane. That is, I substitute the position vector and the normal vector into the formula. So in this case, the position vector, I choose 0, -2, and 5. You can also choose the position vector -1, 3, and 1. So when I find the scalar product of these two vectors, I get 1, 0, 1. So this is the vector equation of the plane. For the final answer, I'm going to change the vector equation into unit vector form, because the vector equation given in the question is under unit vector form. So therefore, the final answer for the vector equation of the plane is written in unit vector form. Next example, find the equation of a plane passes through the point 5, 1, 2 and containing the line given here. When finding the vector equation of a plane, we need a position vector of a point. So the position vector of the point can be taken from the coordinate of the point given in the question. Then to find the normal vector, we need any two direction vector. The first direction vector can be taken from the straight line because the straight line is on the plane. So the direction vector is 3, -1, and 1. That is the first direction vector. To find the second direction vector, from the question we found that we have two position vector. One position vector is the position vector of the point given. Another position vector, that is the position vector from the equation of the straight line. So by using the two position vector, now I can calculate one direction vector. That is, I use the position vector of the straight line minus the position vector of the point. Then I'll get the second direction vector. So now I'm going to multiply the two direction vector. The vector product of these two direction vector can be taken as the normal vector of the plane. Now I have the position vector and also I have the normal vector. So when I substitute into the equation, this is the normal vector This is the position vector. So here I use the position vector for negative 1, 3. I can also use the position vector 5, 1, 2. So when I find the scalar product, that is equal to 13. So this is the vector equation of the plane. Then I'm going to change the vector equation back into ij form. So this is the vector equation of the plane under ij form. Next example, find the equation of the plane which passes through the point 1, 2, 3 and contains the line of intersection of these two planes. So when finding the vector equation of a plane, first thing we need the position vector of a point. So the position vector we can take from the coordinate of the point that is given in the question. Then next we need to find the normal vector. To find the normal vector, we need any two direction vector. From the question, we know that the plane contains the line of intersection of these two planes. So means the direction of the intersection line is parallel to the plane. So now I'm going to find the intersection line of these two planes. So from the diagram, to find the direction of the intersection line between these two planes, we can use the normal vector of the first plane multiply with the normal vector of the second plane. So the normal of the first plane is 2, negative 1, and 1. And normal of second plane is 1, 1, and 1. So when I simplify, I get the vector product negative 2, negative 1, and 3. So this is the direction vector of the intersection line that we can take this direction vector as the first direction vector of the plane. Now we are going to find the second direction vector. Since from the question we are given one point, means we still need another point such that from 2 points we can calculate one direction vector. So here I'm going to find the point where the intersection line meets the xy plane. When the intersection line meets the xy plane, z is equal to 0. Now I'm going to substitute z equals 0 into the equation of plane. So the first plane, when I substitute z equals 0, I get the first equation. For the second plane, when I substitute z with 0, I get the second equation. Now when I do simultaneous equation and I plus first equation with second equation, then I get the value of x 8 over 3 and value of y 4 over 3. So from here I get the second coordinate point. Now I have 2 points. One is the point given in the question, the other one is the point which is on the intersection line. Since the intersection line is on the plane, so means this point also on the plane. Now I can find the second direction vector. That is, I use one of the position vector minus the second position vector, then I'll get the second direction vector. Here I am going to factorize the 1 over 3 so that the direction vector is in integer, that is negative 5, 2, and 9. Now I have two direction vector. One direction vector is the direction vector of the intersection line. The second direction vector is the direction vector I find from the two position vector. Now I'm going to multiply these two direction vector. So the vector product of these two direction vector is 15, negative 3, and 9. Now I find that I can further simplify this vector, that is I factorize the 3. So now the vector becomes 5, negative 1, and 3. So this is the normal vector of the plane. Now I have one position vector and I have one normal vector. Now I can substitute into the equation. This is normal vector, this is position vector. Then when I find the scalar product, that is equal to 12. So this is the vector equation of the plane. Now I'm going to change the vector equation into Cartesian form. So this is the vector equation of the plane in Cartesian form. So that's all for now. Do you understand what you learned today? If you have any question, let me know in Teacher Eileen Maths group. If you find that this video is useful, hit the like button. Don't forget to subscribe. Thank you so much for watching. I hope you keep on learning and keep on watching my videos, and I hope to see you soon. Bye.